So we're going to talk about solving, instead of polynomial equations, polynomial inequalities. What's an inequality again? What's an inequality? Something that has a what sign? Not an equal sign. Yeah, greater than, less than, greater than or equal to, or less than or equal to symbol. Okay, so it's a polynomial inequality. Here are your simple instructions to do this. And I'm going to go through an example to make it a lot easier. But this is a technique I'm going to teach you that is very useful, especially when you get to AP calculus. When you're going to see in AP calculus that this technique is used a lot. It's called a number line test. And it actually works really well. So you're going to factor the inequality the same way you would factor a regular polynomial. So get 0 on one side, factor everything out into its factors. Take out a GCF if you have to, whatever else there is. Now, normally you find the roots of the equation or the solutions of the equation. You're going to do that again, but we're going to call those critical points. They're not the answers. They're critical points. They're either starting points or ending points. They're like their bounds. Okay? So you're going to find the solutions to the inequality, but you're going to treat it like it's an equation. You're going to call the solutions critical points. The critical points are going to be on a number line. So let's say hypothetically that we solve an inequality. Right? We have some inequality is greater than 0. Right? This is just some value. We get, x equals 4 and x equals 2. These are called critical points. We're going to make a number line. What we're going to do is this. If it was a greater than symbol, I'm going to use an open circle. We put an open circle at 2 and an open circle at 4. So that's the next step. It's going to create regions. Take a look. This is like region 1. To the left of the number 2, that's region 1. Right over here. This is another region. This is another region. So where these critical points occur, create regions. We have to test each region by evaluating one of its members, one of its points. So for example, test the number 3, because 3 is between 2 and 4, right? Test 3 in the original. Mark each region as positive or negative and then shade appropriately. So for example, if I tested 3, if I plug a 3 in here and I got an answer of 7, I put a positive sign here. And then let's say I test over here a 0. In this region I test 0, in this region I test 5. And when I test 0, I get negative 4. And when I test the 5, I get negative 7. I label my regions like that. And then I look at my inequality. What did the inequality say? It said, when is this polynomial greater than 0? Which region is greater than 0? Well, what does greater than 0 mean? It means positive. So clearly, the middle region would be the region that we would shade as a result. So this would be your solution set from there to there. Because this polynomial needed to be greater than 0. If I change the symbol to be a less than 0, what would I do? What's the complement of what we just did? Yeah, you would shade these regions over here. Well, if you shade regions between 2 points, this is an AND statement, isn't it? If I shade outward, what kind of a statement is it? An OR statement. Okay, it's the difference in a conjunction and a disjunction from earlier in the year. So let's go through an actual mathematical example to see how this works. Okay? But that's the procedure we're going to take. So in the first one, it's already set up nicely for you. Factor it, please. It should be like a 3-second factoring. What do you got? Jeff? Good. Jeff noticed right away, this is simply a GCF. Just take out a y. There's absolutely no need to look at AC method or cubes or difference of squares or any of that here. A very simple example. Next, I would solve this like it's an equation. This would give me y equals 0. This would give me y equals 3. These are not my answers. These are, again, critical points. Critical because those are your points that separate your regions. Those give you the boundaries for each region. After that, we're going to take our number line. We're going to plot those values on the number line. And we're simply going to test members in each region. Now, this is a less than or equal to symbol, so I'm going to put closed circles above these. Because it's less than or equal to. If it was just less than, I'd put open circles. If it was just greater than, I'd put open circles. So I'm going to test a point. In this region, what point would you recommend I test? I mean, there's no right answer, but there's an easier answer, and there's a more difficult set of answers. What's the easiest number to test in this region? Well, in this region, be careful. In this region, I'd choose 1 for sure. Yeah, negative 1. Don't choose numbers that are bigger. It makes more work for you, right? So choose the smallest possible number. If in the region 0 is in there, test 0. It's easiest. But 0 is not in any region. It's one of our bounds, or boundaries. So in this region, test negative 1. You do it in your head, please. Don't write it in. Ready? Take a look up here. Watch what I'm doing. If I test the negative 1, test it in the factored form. Do not test it up here. Write this down, actually. Put a little asterisk. Test points in the factored form. Test points in the factored form. And I'll show you why, but write that down, please. Test points in the factored form. So here's why you should test points in the factored form. If I plug negative 1 into the factored form here, I could simply see that this is going to be a negative quantity right here. And then negative 1 minus 3 is still going to be more negative, isn't it? So this is also a negative quantity. I don't even care what the numbers are. It doesn't matter, because I'm not writing down a number. I'm writing down whether each region is positive or negative. So if I test negative 1 in both of those spots, it's going to be a negative times a negative, which is a positive. So this region is clearly positive. So again, there's no need to actually evaluate the number. Just think about a value in there and see if it's a negative or positive. So let's erase these now. Let's go to the second region. In the second region, as Will mentioned, let's test positive 1. Testing positive 1 makes this positive right here. Testing a positive 1 here makes this negative, because it's going to be, right, 1 minus 3, which is negative 2. I don't care that it's negative 2, I just care that it's negative. So it's a positive times a negative, which is a negative. And then finally, we test the third region, which I can't erase this for some reason. Let's just cross it off. Testing the third region, I'm going to test the number 4. Why go to 5? Why go to 6? It's not worth it. Just go above 3, but get the next integer. So test 4. When I plug a 4 in here, this is positive right here. A 4 minus 3, right? 4 minus 3 right in this region is still positive. Positive times a positive is still positive. So my regions have been identified, and now I can shade appropriately. Where do I shade? In this problem, where do I shade? Look at your original statement that you started the whole problem off with. Did we want our polynomial to be less than or greater than 0? I mean, in this case, less than or equal to, or greater than or equal to 0. What did we want? We wanted less than or equal to 0. How does Will know that? It's right here. Since this polynomial needs to be less than or equal to 0, we shade the region that is negative, because that's what less than or equal to 0 means. How do I write this as a solution set? I go ahead and I write either one of two ways. In interval notation, using brackets because it's closed circles. Whoops. Or I write it in set notation. What was the variable? Y? Yes, Y. So we have, let's see, 0 less than or equal to Y, less than or equal to 3. Either way to write it is fine. I don't care whether you use interval or set notation. I might ask you on the midterm question and say, answer in interval notation, so I know that you know what that is. So if I specify it in the midterm, you should do that. But on this test, I don't think I really mention it. I don't mention it. Okay, so that's your solution set from 0 to 3, including the endpoints. Does the process make sense? Is it straightforward enough?
Are you only shading, because if you need it to be less than or equal to 0, you're only shading the region that's negative?
Correct. Had it been greater than or equal to 0, I would have shaded the positive regions only. There's a good chance that regions are going to alternate, by the way. It happens a lot. Positive, negative, you have like 4 regions. Okay, so you're going to see that. It's not a coincidence at all. Try this one on your own, please. These problems shouldn't take you very long because the factoring involved is pretty simple in these here. At least the beginning ones, right? Treat this the same way as the last one again. What numbers? Multiply to -8 and add up to -2. You do not need AC method on this one. Okay, you do not need AC method here. Jeff, no glasses today. You had them the other day. Did you forget them? Do you have them with you? Did you need more in them or no? No? Put this out? Sure. I mean, I used to have, so when I was in high school, I had pretty bad, I mean, I still do, because I was bad practice. But I used to not wear my glasses and they would give me headaches every squinting. So just think about it, okay? So you can factor this pretty simply, you see right there. Once you're done factoring, the critical points are going to be 4 and negative 2. So go ahead and set up a number line with 4 and negative 2. Open circles because it's a greater than symbol. It's not a greater than or equal to symbol. Test points, please. Test in the factored form. Morgan, what do you got for regions? Positives, negatives? Sure. What did you get? Negative. And again, right? Doesn't matter. Good. Other ones? Try it. Good. Try 5. Remember to use the factored form. It's a lot easier. Good. Yeah, because it's negative times negative. Be careful. Try negative 3 in both those factors, right? It becomes negative 7 times negative 1. So it's going to be a negative times a negative, which is a positive. So that should be your arrangement. So positive, negative, positive. So M, you answered the question, right? Because you asked it for the last one. What do you think? What are we going to shade here?
It has to be greater than 0, so we shade the positive region.
Correct. So shade the positive regions. And whenever you shade the outer regions, we know that this is a disjunction. So it goes on in each direction indefinitely. What does my solution set look like, Alex? What do I get for a solution set? This one's a little bit difficult, right? We got a few pieces here. Either in set notation or interval. You pick.
The parentheses, negative 2, comma 4.
Remember, where are we shading here, Alex? We're shading the outer parts, right? Not the inner part.
The bracket,
Okay?
negative 2, and then parentheses 4, and then, no, comma 4, then parentheses.
Be careful. What you're doing here, let me just show you, okay? What you're doing is you're giving me the answer for this region right here from negative 2 to 4, but that's not our answer. We didn't shade here, right? We shaded here and here. If I go this way forever, what number do I get to?
Negative infinity.
There we go. So we start at negative infinity all the way to...
Negative 2.
Now what do I put symbol? What's the symbol for like a gap? Do you remember?
Thank you.
Good. And then?
Parentheses 4, and positive infinity.
Very good. Okay, that's interval notation. And in set notation, please. Set notation, what do we have? What variable was it? X, yeah. It's going to be an or statement, right? We know it's an or statement. You have to write the word or. So can somebody describe what the answer is going to be? Daniela, how about you help us with this one? In set notation, what would this look like?
So is it x is less than negative 2? Or greater than 4?
Okay? It's got to be or. You can't be less than negative 2 and greater than 4. It doesn't make sense. It's one or the other. Okay, one or the other. So you've got interval notation and then set notation. The next one's a little bit tricky. Go ahead and try it. Don't just give up on the problem. Think about regions, think about testing regions, even if there's not 3 regions, even if there's only 2 regions, or maybe there's 4 regions, like in another problem we're going to do soon. You still have to test those regions. So what do you have here? Who remembers the word? What is it called when your roots are the same? Yeah, double root or a double or repeated root. Either way is fine. So remember that this is really x minus 2, x minus 2. That's what's really happening here. So the roots for this, or the critical points, are the same. They're both 2. So you can't graph 2 twice, so you can only do it once. We know it's a less than or equal to sign, so it's a closed circle for sure. So how many regions do we have now? Just 2 regions, that's it. We don't have 3 regions anymore because our root was a repeated root. Or critical point was a repeated critical point. Testing, both sides. James?
For the left side, test 1.
Okay, test 1 you get?
And then you get negative times negative, which is positive.
And then the right side?
You get a positive, test 3.
But what did our original polynomial want to be? Greater than 0? Less than 0? What's happening here? What am I going to do? Yeah, it said less than or equal to 0, didn't it? It says the polynomial should be less than or equal to 0. Well, this is a positive region. That doesn't work. This is a positive region. It doesn't work. So what's my solution to this problem? That's the thing you want to say first. But what is it actually? 2. Because you put a closed circle here, remember? Don't forget that at 2, it's equal to 0. So if this were an open circle, and these regions were not true, they didn't work or satisfy the polynomial inequality, it would be, as Chandler said, no solution, had this been an open circle. But because this is a closed circle, the actual answer is simply x is equal to 2. Okay, the answer is literally just 2. Because the question was, what numbers make the polynomial less than or equal to 0? 2 makes it equal to 0. Okay, 2 makes it equal to 0. Very good. Well done, so. Trying to give you anything that you could expect, like a little bit of a variation of each. This is a good one to see. Let's do this one together so we see if people remember. What comes out first? Right away, what comes out? W. And a lot of you are getting much better at that, recognizing the GCF always. And then? And then, what do I do? Why? Oops. Why, Sarah? Okay, good. This is an example of difference of squares, really, right? W squared is a perfect square. 16, 9, 25, 49, 36, 64, any perfect square over here. If you have a difference and they're both perfect squares, simply write it like this always. Take the square root of each, put them here, and do a plus or minus. This is difference of 2 squares. This is a review for your test right here. Like, this is something you should know. Okay, factor. If you ever see difference of squares, even if this had a coefficient in front of w squared of 25, this would be 5w and 5w, because the 25 becomes a 5. Whenever you see a subtraction sign in the middle and a square on both sides with subtraction here, think of splitting it up. After this, it's pretty easy. We get 3 critical points, don't we? Can't forget that critical point of w equals 0. Can't let that go. And we get 4 and negative 4. So how many regions do we have now?
4.
Yeah, we got 4 regions here. And this is a closed circle in every region, it looks like, right? Greater than or equal to 0. Closed circle in all of the regions. We're going to test regions, right? And we're going to look for that alternating sign again. It's going to happen. It will happen. I would use 1 and negative 1 to test those middle regions. I'll give you a minute. When you're ready, whoever has it done, tell me the signs from 1, 2, 3, 4 regions. What do you got for the first region? The farthest left region. What do you have for the furthest left? Nobody got the first region? James, what do you got? Negative. Second region. Keep going, James. Go ahead. Okay. Third and fourth regions? Third and fourth regions? Negative. And then fourth region? Positive. What do we want this to be? We want this polynomial to be greater than or equal to 0. So we have two regions that are greater than or equal to 0. Let's shade them. So we shade this region here, and we shade this region out here. So this is an interesting problem, isn't it? We've got an AND statement within an OR statement. It's an OR statement because it's either one of these regions, but this overlapping region is kind of like an AND statement. So let's write this in set and interval notation. It's not easy to write this one. Help me out here. How do I write this? Interval is probably easier for this one. What's interval notation for this one? Set notation is probably harder. I mean, I don't know. What do you got for interval notation? Morgan, you remember interval notation? I remember, I don't know if you were in the class with us at this point when we did it. Interval notation. Where? Yeah, with brackets and parentheses. For the right one, over here, yep, it's going to be from 4 to infinity. Infinity has a parentheses, 4 has a bracket. -4. And they're brackets. The reason? Remember, brackets are used when it's a closed circle. Infinity is like an open circle. Because an open circle means you never get to that value. You never get to infinity. So it's always going to be parentheses for infinity. Whenever there's a closed circle, you put a bracket. Whenever it's an open circle, you put a parenthesis. How about set notation? Somebody else for set notation. What would that look like here? Again, it's going to be an AND statement within an OR statement. James?
W is greater than or equal to -4.
Okay.
And then W is less than or equal to 0.
Okay.
And W is greater than, or W is greater than or equal to.
Okay. So that's one way of doing it. Now, can somebody summarize James's AND statement, though, to make it a little bit easier? That works. You are correct. But I could rewrite this right here in a much easier way.
-4 is less than or equal to W, which is less than or equal to 0.
Okay, that's how I would probably write it, just to be a little more simplified, but it doesn't matter. Okay, remember, whenever it's an AND statement from like -4 to 0, you can write this interval right here as this in set notation down here. Okay, all this means, just so you know, is that W goes from -4 to 0, including the endpoints. That's the same thing as this. W ranges from -4 to 0, including the endpoints. Or is from 4 to infinity, or everything greater than or equal to 4. Questions on this? This would probably be the most difficult one you'd have, just so you have an idea. The next one we're going to do is a little tricky. I don't think I'm going to put something as hard as the next one on the test, but it's something to think about outside the box. But you should be able to do everything up until this point, just at least from today's lesson there. Okay? You can have a problem where it's like this, and it involves factoring using the difference of cubes. Well, actually, no, I'm sorry. You would not have a problem with difference of cubes. I apologize, because you can't factor the result. But you could have this where it's like, you know, w to the fourth minus 3w to the third plus 2w squared. You have to factor out a w squared. You get a double root. You get two other critical points. So it could be difficult factoring, but the process is the same. So with that one here, this one is really messy. Remember, the first step is to get 0 on one side, right? You always got to get 0 on one side. So we got to get rid of that 6h cubed. We have to do something. We also have to do something with everything else that's going on. So can I get some recommendations as to what I can do here? How might you start this problem? How might you start this problem? All right. Agreed. I would start with that. Then, I can't combine like terms yet because I have that h squared on the outside. So what should I do?
Do the difference of squares where h squared plus 1.
This is not a difference though, right? This is first. That's a sum. But remember, James, you can only factor something once everything is kind of collected. Like I can't just factor this individually while this is still here. I need to get this so I can make this something that I can combine with this or rewrite it somehow. When you're stuck with something like this and you can't factor, obviously, what might you want to do?
Distribute the h squared.
Yeah, try distributing the h squared. It might work. And it does work in this case. If I distribute h squared, it becomes h to the fourth plus 9h squared minus 6h cubed. Well, let me put this in the correct order. H to the fourth, whoops, minus 6h cubed plus 9h squared. Now what comes out? Will? H squared comes out. Really no more difficult than the last one, just a little bit of algebra. That's all it is, a little bit of algebra. Factor, 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 factor. What do I get when I factor that trinomial into two binomials? What does it become? Yeah, this is an example of the square of a difference. It's h minus 3, or quantity h minus 3 squared. So in this problem, you could watch the rest and do the homework, but you're going to have 4 critical points, but you're going to have 2 of them are repeated, right? So in reality, it's just going to be a 0 and a 3. Continue this one on your own, please. Continue on your own. Make sure tonight to do the ground set, finish it up, have it in your car, be on time with it, please. Don't lose points with silly things. After school today. Did somebody come this morning for office hours?
I tried going upstairs. I was in the office, but you weren't there, but I have a to study for.
Okay. Alright. Because it's only in the afternoon in the winters. It's not in the morning.
Okay.
Okay? Alright. Yep, no problem.